Now let's go to question 2. Question 2, it reads as followed. The first term of an arithmetic sequence is 7. So therefore it means A is equals to 7. Then the common difference of the series is 5. So therefore it means D here is equals to 5. And the series contain 20 terms. So therefore our n there is going to be equal to 20. Right? So 2.1.1, it says that calculate the sum of this series. Okay, so now to get the sum of this series, because it's an arithmetic series, you know that we use the formula 2.1.1. we're going to use the formula Sn is equals to n all over 2 bracket 2a plus n minus 1 d, therefore close bracket. So we already have a, we already know what is a, so we're looking for s 20, sum of 20, n is equals to 20 over 2 bracket 2a, it's what, a it's 7, close, plus, let me just write clearly there, plus 20 minus 1, close bracket, then our common difference is equals to 5, therefore close. Therefore when I put this into my calculator, you can pause the video guys and put it in your calculator as well to check if you will get the same answer as me. I am getting 1090. Okay, and that's how you would deal with question 2.1.1. Easy, straightforward, just following the basics. All right, so now let's come to 2.1.2. 2.1.2 says that the original arithmetic sequence is extended to 70. So it means here n 75 to 75 terms. The sum of these 75 terms is equals to that. So it means now this is S 75 terms. Using sigma notation, write down an equation for the sum of the terms added to the original term. So now it means the sum of this m added to the original term. Remember the original one was what? Was S20. So now something was added here, added to get us to sum of 75. So you want to know what is added here in between. So therefore the difference between these two should give you what is added here in between. So therefore it means now what is added is going to be given by sum 75 minus sum at 20. Okay, which will give us sum 75. They already told us it's 14,400 minus 1,090. So this gives us how much? This will give us the sum that is added is going to give us 13,310. So this is what is being added. However, what are they saying? They want us to say you're using sigma notation, write down the equation. So now they want us to use sigma what? Notation. Right. So now let's go ahead and find the formulae of these terms. Remember, this is an arithmetic sequence, so the formula that you're going to find, we're going to use Tn is equal to a plus n minus 1 close bracket d. So therefore you know what is the first term. The first term is 7 plus n. Here we're looking for the nth term, which is the general formula, and then the difference between the terms is 5. So therefore you can simplify this, say 7 plus 5n minus 5, which will give us 5n is going to be plus 2. So therefore this should be our Tn. All right, so therefore it means now we can express this in terms of sigma notation, because now we already have. And sigma notation, what do we have? So if we were to write this in sigma notation, we want to have to start from where? Remember, we are looking for what is in between these two things here. So it means Sn here, what was 20, so we're looking for Sn 21. We're gonna start from 21. Gonna start from 21 up until 75. So therefore it means here our n value here, we must start at 21 and then up until where? 75. Guys, I hope you still remember sigma notation. You did it in grade 11. So this is how you would express it. You are starting to calculate here up until the end here at 75. What, using which formula? Using this formula, 5n plus 2 close bracket. Then our sum will have to be 13. Remember, this is the sum of what is added. So this is how you would express this in terms of sigma notation. All right, so if you've got any questions, guys, please let me know on the comment section below. I am Gaston Bampala. Welcome to Maths with Gaston. If you have not subscribed, please subscribe. We do content concerning mathematics from grade 10 and also grade up until grade 12. So let's move on to 2.2. Okay, so 2.2 says the sequence of the first difference of a quadratic pattern is given by that. Okay, so I hope that is very clear. So basically, what does this mean? Just to explain this question here, this means that what do you have? You have got term 1, term 2, which is a quadratic, term 3, and then you also got term 4 here. So when you take the difference of these terms, you get 1. You take the difference of these terms, you get 3. You take the difference of these terms, you get 5. Okay, and therefore clearly here you're going to get 2. Therefore here also you're going to get 2. So basically this is what it means here. This is the first difference of the quadratic pattern. It gives us this pattern right here. All right, so let's go on. 2.2.1. It says if T99 of this quadratic pattern is given by that, calculate T98. Okay, so now here, guys, you need to think very carefully about this one. What you need to do, they are saying if T99 of a quadratic pattern, it means you have gone around here and then you get to T99, 98 here, and then also T99 somewhere there. So they are saying T99 of this pattern, it is given by 9632. So now they want you to find this one. So it means here in arithmetic sequence you must have got, because this is T1, 2, 3, 4. So it means here in arithmetic sequence this year should be T98. So it means what you can do, you can say T98 minus that will give you this value here. Okay, I hope it's clear, guys, because in order for you to get this one here, T4 minus T3 gives you this one. So in order for you to go back, you must say T4 minus that, it will give you T3. Okay, so now I should have illustrated this. Oh yes. Okay, it means here now what you can do, you can go and find the formula of arithmetic. Okay, because we know that a here it's equal to 1 and then the difference there is equal to 2. So therefore T98, when you have to find this term here of arithmetic sequence, is going to be given by, you're going to use this formula here. Okay, first term is 1 and then T98 minus 1 and then D is equal to 2. So therefore T98 of arithmetic sequence. Okay guys, this is for arithmetic sequence, not for quadratic, because for quadratic we have got nothing that is given there. So this will give us, if I put this in my calculator, is giving me 195. Okay, so it means it is 195 for arithmetic. So it means here the number here is what? 195. So what do you do with that 195? To go back here, to go backwards here, you need to minus this 195. So you're gonna come here and say therefore T98 for quadratic now is going to be equals to T99 for quadratic minus T98 from arithmetic. The one we just calculated now, which is this one, the one for arithmetic, guys. Don't forget, okay? Don't get confused between these two, guys. Don't get confused at all, okay? All right, so T99 is going to be 9632 minus, and then the one for arithmetic, which is 195. Therefore, it gives us T98 for the quadratic is going to give us I'm getting 9437. Okay, great stuff. Okay, and that's how you would deal with a question like this one, guys. Moving right along, let's move on to 2.2.2. Right, so 2.2.2, it says here if, okay, if it is further given that the third term of the quadratic pattern is 34. Okay, the third term, okay, they are saying this is T3, the third term, it's equals to 32. Determine the general term of the quadratic pattern. Okay, they want us to find the formula for the quadratic pattern. Okay, so what you would do here, you already know that if you are given something like this with the pattern, if you are given something like this with the pattern, if they said what? The third term is 32. Oh, okay. If they have given us 32, let me see. 3, 5. If they say the third term is 32, okay, T1, T2, okay, T3, this minus that will give us 1. This, okay, I'm doing this wrong. Okay, let me just figure it out here, guys. I'm just going to check something. Okay, here we go. Let's see, T1, T2, T3, and therefore T4, and then we're summarizing this now, gives us 1, T minus DT gives us 3, therefore this minus that gives us 5. Okay, so now they've given us this one here. They are saying this is 32, so this plus this 32 minus 3, 32 minus 3 should give us term 2. Okay, guys, now here you are just working backwards to go find the other terms here, so that you will be able to use this here, right here. You're gonna have 2 there. Common difference here is 2. So if they say the third term of the quadratic pattern is 32, so you need to go backwards. This one minus 3 should give us how much? Okay, so it's 32 minus 3 is giving us 29. There is 29 from 32. Therefore, this one minus 1 is going to give us 28. Okay, great. Okay, so with that, now we can come here and say, remember, guys, this it's you must know by heart. Okay, you must know that this, the common difference is equals to 2a, and then therefore the first term of the first difference is given by 3a plus b. It's equals to that, and therefore a plus b plus c is equals to that term there. Okay, so now let's see, let's go ahead. 2a is equals to 2 divided by 2 divided by 2, therefore a it's equals to 1. Oh, I'm forgetting something, guys. The quadratic equation formula generally is supposed to be Tn is equals to an squared plus bn plus c. This is what we're looking for basically. So we need to look for a, we need to look for b, we need to look for c as well. All right, so we already got a there. Let's continue. 3a plus b is equals to 1. Plus b is equals to 1. So we know that here plus b is equals to 1. Okay, so now with that, take 3 to that side. You're going to have a 1 minus 3, which gives us b is equals to minus 2. Great. So now to find a, you're gonna come here, use this one here. You're going to say a plus b plus c is equals to term number 1, which is what, 28 in this case. So a, we already know a is equals to 1, b it's minus 1 plus c it's equals to 28. Therefore you're going to have minus 1 plus c is equals to 28 here. Therefore take 1 to the other side, c is equal to 28 plus 1, which is equals to 29. Okay, so therefore it means we can come here and substitute this into our formula. Therefore Tn is equal to a squared minus 2n plus 29. This would be our general formula, guys. So you can check our general formula by substituting term 99 to see if you are going to get 9,632. All right, and that will be all for question 2. I am Gaston Mapala. Let me see you in question 3. Interesting question indeed. Make sure that you subscribe, share this video with your friends, your family, your cousins, and also your classmates.